You strike while the iron was too hot. I had to strike perfectly.
So, I did lots of work for you. I did lots of work for you and I finished. Oh, that's not our class. I was sure it was open. So, lots of work and I finished 36 videos and 52 pages of writing in 1 week.
Wow.
Because I started on the fall break on Sunday, I think. So now you have so much stuff for this exam. You have to do good. If I put so much effort into something I already knew, then you should put effort into practicing these things which you are afraid of, right? Because I knew that all. Why did I even do all of this? This review might be changed like next year, and all this work I did will be wasted. So make sure you kind of use it. Practice exam counts towards your homework, so you better do it. Just get 100 points. It's very easy.
Wrong one.
And it's pretty easy.
Exam 1.
Oh, yeah. And then this is what I prepared for you. And then all my video solutions, step by step. Every single problem has a video now. Every single problem. Think about that. Kelly and Sagar did an amazing job. They gave me solutions on everything. And then I just wrote it down and then recorded myself. You will hear I'm a little bit confused in some videos because it was tiring. It was very tiring. I got lost in some calculations, made a couple typos, but that was the price of making it fast. But done. Look at this. 52 pages of written work. And all of these have videos. 36 YouTube videos. Actually, more than that because some homework is also there on the video.
I found my new favorite playlist.
It's amazing. Look at the recent announcement. So look at the announcement. My recent announcement says what is that and what to do. So people ask me how to do good on the exam. Exam is here. It's ready. It's on my table. I will only change a couple problems, but all the problems are from the review. We're too lazy to make something extraordinary. There's one problem there which you never seen before. I plan to change it to the exam review problem. So, do I want you to fail? Not really. It's hard to grade if you fail or do something weird on the exam, and then everyone is sad when you fail. So it's actually, objectively speaking, it's good for me if everyone passed the exam with a good grade. It's easy to grade. You're happy. I'm happy. Fun. So your job is to get really well with this review stuff. The review is posted on the website. It looks like this. And then I made solutions for all of this, and videos for all of these problems. So your job is to just be very good at it. Videos are here. And what else? Here's the videos. All the videos are here. 36 videos. Maybe you don't need to watch all of them. Maybe you're good at this stuff. But how to find out? You have to start practicing. Practice exam is here. Quizzes, keys are all posted, even the recent one. Everything is posted for your convenience to be good on the test.
And exam key?
No. No exam key.
Professor, you low-key make me want to cry for the fact.
Right?
Thank you.
How crazy! Like, why did I do that? How crazy is that? But do you know the worst part of this? Now you will expect me to do the same thing for second two exams, and that freaks me out already ahead of time. I'm like,
now the pressure's on for me because my professor is doing this for me. I gotta get a high grade.
You better, yes. I definitely don't judge if you don't do well. I'm very low key about that, but at least if you will be on the edge of passing grade and you will approach me at the end of the semester, the first thing I will ask you, guess what? Did you do my review? Did you take the practice exam? And you will say, yes, but I can check. I can see. And you didn't. So, and you're like, did you skip my classes? I always ask these questions. And then you ask me for the recommendation letter, and students do ask. That's the first thing I ask. Were you active at the group quizzes? Did you come to class? Did you actually practice things? And that's what you're supposed to say something, So, that is what I wanted to say. Let's start the review. So, exam on Wednesday. Do you think it's possible if we start early?
How early?
5 minutes early.
I'm going to be here for about another 2 hours, so yeah.
That interferes with my class and ends like 5 minutes for this.
Yeah, maybe just run a little bit early. Because I don't think we can stay later because of The next class.
I think we should all protest.
No, we're not supposed to stay later, so she's right. We're not supposed
Do a
to.
silent protest. Sit here.
But usually nobody kicks me out. It's the first time in 5 years someone actually kicks me out. And then she looks so nice, I don't want to argue with her.
I'll argue with her.
Exam. I think that'll work. You can't give us all zeros.
Yes, you can.
Okay, let's go through the review. You know my strategy on the reviews.
Yeah, nobody show up.
You know my strategy. I go fast. You make a note for yourself as a reflection. Are you good at this or you're not good at this? But you can stop me really fast if you want to. But not for too long because we have 1 hour to finish everything.
Where is this professor? Or like what? And the one note.
It's just a free. It's an empty note.
Oh, it's an empty note.
But if you want, I can sync it. I'm syncing it. So partial derivatives are on the test. Some of you feel concerned about that. But to be honest, there is a way to learn them without knowing the formula. And that's what I explain in my videos, how to do that. Which is, for example, partial derivatives. Of course, not the easy one. We're going to do chain rule only on the partial derivatives.
Oh, thank God.
Chain rule. So not the easy one anymore. Nobody gonna test you on easy derivatives, to be honest. So what you need to learn is chain rule, which is already 11.5. 11.5.
Are you recording, Professor?
Yeah, thank you. This is the problem. So please concentrate and make your brain work right now. It will be very contributional for you if you wake up right now. This is the important time to wake up, okay? Just making it clear. If x is a variable of two other variables, and y is the variable of two other variables, and z is the variable of two other variables, and then w collects x, y, and z, how to find derivative with respect to anything I can ask you. For example, find, and that's going to be random. I can ask partial derivative, partial. I can ask partial derivative with respect to x. My music is playing. Partial derivative with respect to s, partial derivative with respect to z, partial derivative with respect to t, and so on. Partial derivative with respect to x. You don't dig into s and t. So you should see it, I see it as a pockets. So your pants, and you see my dress has pocket, right? What if there's a secret 2 pockets inside of each pocket? So the outside pocket is my x, and then y, and then z. Say I have 3 pockets, right? Then each pocket has inside pockets. One s, and the other one is t, and same here, and same here. So it depends which one I was asked to dig to. And I said there is a candy in the pocket x. Then it's just the outside pocket. That will be derivative of this function with respect to x, which is just 2x. Make sense? We don't dig deeper, then it's just 2x plus 0 plus 0. But if they say no, go deeper, there's a candy in the location s. But there's 3 locations that have s. So I have to go to all 3 deeper pockets and dig deeper there to find the candy s. So that's why it has pluses. The first digging idea is you go into x. So that's going to be partial derivative of w with respect to x. I'm unlocking the outside pocket, which is called x. Times means and. In logical classes, if you take logic, it says and is times. Now I need to take a derivative of x. Take derivative of x with respect to s to get this candy. So you see, I don't need a formula to remember this. I just need to understand how it works out. This is not the and because it's or. Or there's also left pocket, which is called y. And that's why you do plus. Plus means or. Let's dig into y. dy with respect, no, dw with, so w is outside over here. W plus u goes into 3. This w is my hand. So my hand goes into y. That's dw with respect to y. And now there's 2 options hidden inside of my pocket. And I'm going to the left one. Y with respect to x. You see, product is and. Or, again, there's a third version. I'm going to the pocket, say on my back, somewhere over here, hidden pocket z w with respect to z, and then z with respect to s. As you can see, this is how you unzip the pocket. X to x, y to y, z to z. So I don't remember the formula. That's why it's always hard for me when people ask what's the formula. I don't know. I know the process. Formula there happens from the process, not the other way around. So I don't memorize the formula. I just know how to work logically from what is going on. From x to s, from y to s, from z to s. And then right away, I'm actually starting finding those derivatives. I'm not even making a list. I'm just start finding them all. Because it's faster this way. W with respect to x is 2x. X with respect to s, looking at this equation, let's call it number 1. That's just t, because s is the variable and t is a constant. Plus w with respect to y, 2y. Y with respect to s, looking at equation number 2, that is cosine t. Plus w with respect to z, that's 2z. Z with respect to s is sine t. Done. This is already the most important part here. We found derivative. Now it has too many variables in the answer. We're supposed to end up with the variables only in terms of t and s, and we have x, y, and z. So you just plug them in back. Your x is st, so it's going to be 2 st times t plus y is s cosine t plus z is 2, well, because times 2, s sine t times, I will zoom in, sine t. And then they ask you to plug things, and you plug things. If t is, they told you in this case, and now plug stuff. S is 3, t is 0, and you just, okay, 0, 0, 0, so immediately it makes it easier. This is perfect problem on a test. Yeah.
Can we leave it like this on a test with just all the, or do we need to like multiply the distribute?
You're asking, if it's a multiple choice, you have to choose, and multiple choice will look pretty. Multiple choice will look something like that, of course. We don't leave it unsimplified usually. So that's a good question. 2s sine square t. But usually we ask you to plug something like s equals 3, t equals 0, and that's easy to grade.
Okay.
And you just
Thank you.
Is it gonna be like even further than that, like cosine squared or sine squared is 1? So it's
no, that's good enough. That's good enough. So that's partial derivatives for you. I jumped into 11.5 because we're not going to check 11.3. We are going to channel right away. So now everything else will be checked in finding plane, tangent plane, and stuff like that. So practice these. This is important. It's literally learning channel from scratch. So you need to be good at that. 11.4 is the one that people get confused with. So let's do that. 11.4. 11.4 asks about tangent planes and approximations. Did you like approximation topic, tangent planes?
Yes.
Well, I'm always asked to put it on the test or not. And approximations. Because right now there is a problem on approximations on the exam, and I usually don't like them, but if students like them, I keep it there. Do you remember what I'm talking about?
Yeah.
It's a L. Remember there was L?
Oh.
L approximated, la 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 la. See, if you don't remember, that's kind of not a good sign. But tangent plane, let's do first tangent planes. We learned the new equation, z minus z sub 0 equals partial derivative, just like y equals mx plus b in 2D, m is your slope. Slope is a derivative, but now we have many derivatives, so we have to take this into account. And that's why this new equation comes in. It used to be y minus y0 equals slope x minus x0, and now we're just increasing the dimensions. And derivatives became many different derivatives. So derivative with respect to x times x minus shift. It's a shift there. Derivative with respect to y, y minus shift. Kinda, that's all you need to know. Z minus z sub 0. So we'll learn this new equation, tangent plane, how to find partial derivatives. And then from there, linear approximation showed up. Linear approximation, L was approximately, you move this part to the right, and it becomes f. Z sub 0 is f at a and b. if you want. It's the same meaning, just a different notation. Everything else, derivative with respect to x at AB, x minus a plus partial derivative with respect to y at the point AB, y minus b. So that is the linear approximation. Do you remember this?
No.
So should I put it there or not?
Yes. Yes. Wait, no, guys. If you remember this, it's an easy problem.
But I don't remember it.
I will remember it.
I don't know. Let's decide at the end, I guess.
I remember.
So find the linear. Do you remember how to do like find the linearization of x squared of y? Like, do you know how to do that?
Yeah.
Oh, okay.
No, I don't remember.
At minus 5 and 4.
Yeah.
So I'm kind of debating, should I put this in a test or not?
You should.
But there is definitely tangent plane. There's no differentials in the exam. We had differentials if you want, if you remember. I did not put it there. But there is an equation of a tangent plane on the exam. Yes.
Will you ask on the exam, like, if we have to, like, if you give us an equation and we have to figure out if it's an ellipse, so like a hyperbole? Or...
Oh, don't jump. No, I'm not going to ask that.
Okay, good.
But it gets further. No, we're not requiring. I was required as a math major in Ukraine to memorize all the shapes and all equations for them. A, B, C for elliptic, ellipsoid, and paraboloid and stuff. You guys not required anymore because of, I think, modern age. You can just Google it. So mostly you need to have intuition what the shape of the function is, but we're not requiring that. Yes.
Are contour plots on the exam?
No.
Thank
Plots
you.
taking too much space, so I don't want to put that. No, contour plots are not on the exam, and you guys don't do well on them, so I try to avoid to put them there because you don't do well. I can see that. Tangent planes. Find it, but tangent plane is on the exams. Let's figure this out. Find a tangent plane and normal line. Normal line. Tangent plane and normal line. And I give you the equation and the point. Now you remember the formula, hopefully. It looks like the same in 2D, and then just you add more variable. And I give you a point, because remember, tangent is supposed to touch or kiss the graph at some point, because that's the translation of tangent, means kissing. Now you remember the formula that you need to find. I just wrote it over here in the box so we can stare at that one in the blue. You just need to find partial derivatives. Partial derivative with respect to x and partial derivative with respect to y. And that's where we check if you know how to take partial derivatives. Last time reminding you, x is a variable, everything else is a constant. 3 goes down, x squared times y minus 7y squared. Hopefully you're good at this. I think you are.
Yeah.
With respect to y, now your brain should switch and say, okay, y now is important. 4x cubed times 1 minus 7x to y. This is good. You did this. Good job. Now you plug your point. To save some space and time, we actually can put a bar which says at. That's an international notation. At. And you can plug the point. There is no z. And maybe for your convenience, write down with a pencil not to mess up which one is which. In this case, it's 1 and 1, so it's convenient. Plug it in and it gives you 5 and minus 10. Those are slopes. Now we have more than one slope because we have more than one dimension. So it's a slope to this direction, this direction, this direction. Now we are almost done. Remember the equation needs, so equation of a line needs, of the equation of a tangent line or tangent plane needs slopes. We have these. Needs x sub 0, y sub 0, and z sub 0. And we have that given. Sometimes you need to find z sub 0, but it's given. So we can write down the equation right away.
Wait, what's c sub 0?
Here. 1, 1, and minus 3. It was given, but actually I could actually hide it from you. Then you plug everything into the original, and you're supposed to get minus 3. If you plug it here, let's see, 4 minus 7, that's minus 3. Yeah, matches, 1 and 1. So now we can start writing the equation using these informations. Z minus z sub 0, which is minus 3, equals, first slope is 5, x minus 1, second slope is minus 10, y minus 1. Then almost full credit, but you have to simplify it just for my convenience of grading. It's just faster to grade if you simplify this. So it's nice if you have z equals blah, blah, blah. But to be honest, this is already the answer. If I see this, it means you did not mess up. Right? Yes.
What if there was a z where we have to like solve for f of z,
Yeah.
and we set the equation equal to 0?
Oh, no, that's different. No, that's too complicated. Yeah, we don't do that. Sometimes if there's no z, you just plug in these two and you get your z. You don't have to solve for anything.
No, like, it's in the equation, it was like f of x, y, z. Like,
You wouldn't 4 dimensions.
Why would you solve some?
No, that would be 4 dimensions then.
never
Yeah.
mind.
I think you're expanding. Yeah. That's what I'm also thinking. Yeah.
Everyone's both.
How do you get 4 minus 7 equals -3?
What? Oh, this one?
Yeah.
So x is 1 and y is 1. So I'm plugging 4 1 cubed times 1 minus 7 times 1 times 1 squared. So it's 4 minus 7. 1 are convenient numbers, that's why I immediately got it. 4 minus 7 is minus 3, so matches. Z is minus 3.
Quick math.
Yeah. So, and then for the normal line, that is a tangent plane. That is tangent plane. See the difference between planes and lines. Plane is 3-dimensional object with x, y, and z. Line also have x, y, and z, but we're asking for a normal line this time. Normal line. Your job is to have some kind of imagination. Here's your floating in the air carpet, which is a surface. Surface floating in 3D. Tangent plane is touching or kissing the surface at one point. Normal and the tangent vector looks like that. Normal vector is sticking out like a needle. So to find normal, you use the idea of negative, just like in calculus 1, to be honest, it's the same thing. For the normal is negative reciprocal. Negative means negative, reciprocal means 1/5. Minus 10 gives you 1/10. For the normal, it will be the opposite and divide by it because it's perpendicular. We did the same thing in calculus 1 when we found equation of a tangent line and equation of the normal line. So that's what they are saying here. And then the rule is still the same. Now, instead of z minus 3, it's still going to be z minus 3, but now divided by 1. X minus 1 is still there, but instead of times 5, it will be over minus 5. And then y minus 1 is still there. Point did not change, that's why. The point is the same. And then over 10.
Plus.
I'm doing equal. I'm doing this like triple kind of thing. Like so.
Wait.
It's one of the ways to write down. Oh, yeah, you're right. Plus. Sorry. Yeah, good point. Plus. It's one of the ways to write it down like so. So as you can see, over. Yeah. Because let me write down. It's minus 1/5 and 1/10. Like so. Yeah.
That's just z over 1, right? Because z doesn't have its own.
Yeah.
You don't want to simplify?
Yes. So you kind of have to. Yeah.
Why did you do divided by 1 on the z side?
Anyone wants to explain?
Because z doesn't have its own slope in this case.
Yeah, to show it. It doesn't have its own slope here. So x and y have slopes, but z, it's 1. It has a slope, but it's 1. Yeah. Yes?
How can we find z naught?
Z naught is here. Usually it's either given, like so. This is...
Not given.
Huh?
If it's not given.
If it's not given, you take it and you plug it into the original function. To find z naught, plug into original. Make sense? Good question. Okay, let's move on to the... So learn how to find the equation of a tangent plane. That's what we just did right now. That is going to be on a test, definitely. There's a problem in the review about differentials, estimating the cylinder can. If you like it, I can put in a test. I don't know. It's kind of short, but annoying. I don't like it either. So, gradient. And then everything else became very important after this. When we learned chain rule, of course it blows up into the gradient idea. And I told you, you are in this class for gradient. One of the most important topics in this class is gradient. If you leave this class and you don't know what gradient is, that's horrible. It means I failed, you know. Gradient is the core of this class. Vectors, at least some kind of idea. You might forget all the formulas, but the idea of the vector field, which we're going to learn after the exam. What vectors do, the size of them, how do they interact, how do they add up, multiply, perpendicularity. You have some kind of intuition about this, even if you forget everything. And gradient. Gradient and double integral, which is volume. Even if you forget how to find it, the intuitive idea that double integral is volume, that's important. So those three things are core things of this class. Gradient is literally the most easy idea you can imagine. It's just a collection of partial derivatives. It's a convenient idea to put partial derivatives into one notation. I don't know, T, M, whatever you want. Just collect them all in one line and call a function somehow, and we call it gradient. So it's a nice idea. But the thing is, again, the floating curtain in 3D, derivative with respect to x, which is looking over here, with respect to x will be something like this. Derivative with respect to y will be maybe something like this. Derivative with respect to z will be something like this. Fourth dimensional gravitational forces like this. Collection all of this gives you the maximum change, because all of these are changes, right? How fast something is moving with respect to speed, with respect to gravity, with respect to mass, with respect to temperature. All of them together gives you the maximum change, and that's what we call gradient ascent and gradient descent. So it says if you're hiking the mountain, taking into account temperature and steepness of the mountain and x, y, z variable and gravitational forces, you should hike over there. So that's the cool thing. Gradient shows you if you want the hardest hike on this mountain, go over there, because it gives you the maximum rate of change. Oh, you want to know how bad the hike is going to be? Take the length of the gradient. Magnitude of the gradient gives you the maximum rate of change. So that's kind of the cool idea of that. So you need to learn how to find, plug in numbers that make sense. Gradient functions, it's going to be there. But the biggest application of the gradient was tangent line, again. So applications. Now we can use gradient to find a tangent line instead of normal, instead of what it before. So we give you a function f equals x squared plus 9y squared. My handwriting is getting worse. And then we give you a point, of course. So 10 and 2. And you see z is not given, right? So that's going to be a practice for you how to find it. Tangent line solution. It's going to be instead of, well, we're going to start with finding partial derivatives. 2x, partial derivative with respect to y, 18y, at 10 and 2. At 10 and 2. That gives you 20 and 36. Right? What do you remember we should do now? Who remembers?
What?
To build the equation of the tangent line. Yes?
So wouldn't this just be the gradient at 10, 2?
At 10, 2.
So at
yeah.
the gradient at 10, 2 would be 20, 36.
Yeah, so now what should we do? To build the equation of the tangent line.
20 times x minus 10.
So it's going to be, let's check, 20 times x minus 10. That's the part I heard. What else?
Plus 36.
Plus 36 times
Y minus 2
y minus 2.
is equal to something.
What?
Z.
Z minus, and how to find z? I need to plug into the original. So let me do that. Z will be x squared, which is 10 squared plus 9 times 2 squared. And I have it here. It's actually 136. 136, like so. So, 136. All agree or not? What do you think about that? The thing is That is not correct. And that's why I wanted to bring attention to this example, because I noticed people messing this up.
Isn't it gradient over magnitude?
The thing is, gradient has an interesting property that it is perpendicular to the curves, to level curves. Yeah. If you remember, we taught you that gradient is perpendicular to level curves. So actually, gradient at some point became a normal vector to the plane. So gradient, even though it has derivatives, it's not a tangent vector. Just like I told you right now, tangent vector shows you this direction, this direction, this direction. But accumulation of them all actually is perpendicular to everything. Because we're going back to the class 1 of this class. If this is the kid that drags you to the toy store, and this is the kid that drags you to the Ferris wheel, and this is the kid that drags you to get ice cream, you are not going to any of these directions. You're going somewhere up, somewhere that accumulates all the forces when you're holding all those kids and they're dragging you. So in 3D, think about that. And the theorem showed that indeed this gradient vector f is perpendicular to the level curves. And level curves look like that, if you remember. So we're using it as a normal instead of just plugging as derivatives. And that is what confusing part here. So this is not going to be here. Instead, we're going to use negative reciprocals again. Well, not, I would say like so. This is the best way, I think, to explain. The gradient is 20 and 36. So we're going to use m as a negative reciprocal of, I would do it like this. The tangent line slope, let me finish just a second. Tangent line slope is going to be minus, not reciprocals, yes, minus 36 and 20, like so. But it's I can't imagine it as a negative reciprocal, even though we don't really divide on that. So it's gonna be actually y minus 2, that is correct, so this part is correct, multiplied by, let's do negative 36, equals x minus 10, that is correct, multiplied by 20. Oh, it was actually good. Okay.
Yeah, so my question.
Yes.
That's kind of my question. We didn't even do anything with the gradient. We just took the derivatives like normal. We
Yes.
didn't touch the gradient. So the first equation would be correct, right?
Well,
Because all we did was solve for a tangent plane. We didn't even do normal vector or anything to do with the gradient.
yeah, I can agree with, yeah. Let me show you this.
We don't worry about the Z.
No, it would still be going in the direction of the gradient, not the tangent line.
Yes, yeah. Not the tangent line. That's what I'm trying to explain. So it's going not towards the tangent line. It goes perpendicular. So the tangent line has a slope minus 36, 20.
Why didn't we get the same thing then? Because you said
Because minus 36. So let's see. Minus 20 over 36. Kinda, that's how the best way I can explain it. Yes.
didn't aren't they supposed to be 1 over negative 20 and then 1 over negative
Let me see. Just equation of the line, yes?
So I got a little confused here because isn't the slope of the x value 20, the slope of the y value 36? So if you wanted to do the factor of this, wouldn't it be 1 over negative 20?
Yeah. Okay, I will explain. So some questions I know how to answer right now. Others I actually don't understand why it's not clear. There's no z here because it's not equation of the plane. That's equation of the line. Line is a line. There's no z is about planes. And the second thing is kind of, that's all. Anyone else wants to explain it maybe better than me? Yes?
Well, my thing is, I was a little confused. We started with gradient, like the intro to this question was about gradient, and then we didn't even touch the gradient in this question.
No, gradient is these derivatives. Oh, that's what your question is. Gradient is the accumulation of these derivatives.
Yeah. Okay, so I agree. Then
Here it is.
Yeah. Then why is this why did the value switch and it become negative? Yeah.
Okay, I will check at home then. Maybe it is not the way I think it is. Yeah, I will check at home and I'll then let you know. Yeah.
Shouldn't the 20 deal with the y and the negative 36?
Yeah, that's what they all asking. That's what everyone else asking. Okay, I will keep this and I will post tonight what I wanted to say about this. That's weird, I'm stuck with this as well. Let's move to the directional derivatives. Let's see. Directional derivatives. So directional derivatives will have at least one problem. Do you know the most important part here? Yeah, sorry about this. I will let you know about that problem later.
Just don't put on the test.
Yeah, kind of. That's also a good point. If you stuck and I stuck, that's probably not a good idea to put it there. Right. So that's a good idea. So if I give you a function, it's not y, it's z, a function as x arctangent of y over x. No, don't be scared. It's actually not that bad. Y over z. Then I give you point minus 8, minus 8, minus 8. And I give you a direction. So it says, find the directional derivative of the function at the given point in the direction of v. And v is some random vector. Either you see it as 10i plus 7j plus 7k. Don't be afraid of this notation. Or you see it as a vector minus 10, 7, 7. If you see a keyword direction of, this is the problem you should do. Do you remember how to do it? They're asking you to find as capital D, u. Capital D, directional vector in the direction of u, of f usually, but I don't know, some people in books don't even write of f. That is a product. What kind of product? Dot product, which is a scalar product, which gives you, f, which gives you a number, times u. This is the formula. So they ask you to find gradient, which is just all three derivatives really fast. And then you need to find u. U is v over v, right? Do you remember that?
Yeah. Unit vector.
Unit vector of a given directional vector. If it's already unit, you're lucky, but I can see on the test they don't want us to put the unit vector. They want you to actually unitize it. So step one, you can start with a simple idea to find u. U is v over v. So it's going to be minus 10 and 7 divided by a huge square root of 100 plus 49 plus 49. This is how I do it, you see? Fast and good writing. You can simplify. Don't criticize. 2. Find partial derivatives. I right away writing the vector. I don't even write down separate derivative. Too time consuming. So I'm looking at derivative and I find partial derivative with respect to x. Arctangent of y over z, comma. With respect to y, x stays. Arctangent derivative is 1 plus everything inside squared. What is inside? Y over z times derivative of the function inside. Derivative of y over z with respect to y is 1 over z. If you're confused right now, that means you're stuck with chain rule from calculus 1 and 2 classes, so just take time after the class and read it through carefully, or you watch my video. With respect to z, the same idea, x over 1 plus everything inside squared, which is y over z, but now times derivative of y over z with respect to z, which is minus y over z squared. that is also chain rule. Derivative of 1 over z is minus 1 over z squared. See, I found the gradient right away. Plug minus 8 minus 8 minus 8 minus 8 minus 8 minus 8. And you will get surprisingly a very good number, because minus 8 over minus 8 is 1. Arctangent of 1 is pi over 4. So the answer is actually really good. The vector becomes pi over 4, 1/2, and minus 1/2. Very nice. If you plug minus 8 minus 8 minus 8. Answer. If it's a multiple choice part, we're going to give you answers as vectors and points numbers. You need to know that the directional derivative, the result of this question, which sounds like this again. Find the directional derivative of the function. The answer should be a number because it's a scalar dot product. Dot product should give you a finite number. DUF will be a product of f and u. So you carefully multiply those two vectors you found. What vectors? U vector is this. So it's going to be minus 10 over square root of 198 times the first number component of the gradient pi over 4 plus 7 over a square root of 198 times the second component 1/2 minus, well, let's do plus 7 over 100 of 198 times negative 1/2. So it's not supposed to be a vector. It should be plus, plus, plus. And the answer is minus pi 5 pi over 2 square root of 198. You will see keyword there, directional derivative. Immediately eliminate choices of the vectors answers. It should be number. What kind of number? Now you have to calculate it. Yes.
I just had a question. Are we going to be getting things like the z equals x arctan y over z? Because I feel like that's testing us more on our ability to know the derivative of arctan than our ability to know
Z over what?
So our equation is z equals x times arctan of y over z.
Yeah.
And I feel like that's
Oh, yeah. No, of course it's more example for homework. Yeah. The derivative will be, let me see. The derivative will be a little bit better. It will be a little bit easier. I agree on that. Don't stuck with the chain rule and stuff. Yeah.
I think I'm more likely to study the derivative of arctan than I am to study.
No, good point. We kind of assume you're good at this, but maybe not. Critical points. Last 10 minutes. Let's really fast review critical points and double integrals. Yes.
Can you scroll up to what's like the triangle with the f called?
Gradient?
Gradient, yeah. Next one.
Okay.
Critical points. Yeah?
No, can you scroll up a little bit farther?
Yeah.
So I'm just confused on the derivative. Yeah, so what are the second two values? I'm just having a break.
These ones?
Yeah.
Oh, these are derivatives of this complicated function with respect to y and with respect to z. That's why they look so horrible.
Okay.
So check later slowly and you will see that's the thing. With respect to y and with respect to z. That's what it is. Critical points. Remember we were building the determinant stuff? How to find if it is local, mean, max, or a saddle point. A saddle point. You build D, which is second partial derivative with respect to x, second partial derivative with respect to y, mixed ones which are the same almost all the time, so you don't have to recalculate twice. Find this number and C at the point, right? So like A and B. Find this number and see the sign of it. So if it is negative, it is so sad, right, that it gives you a saddle point because it's very sad. Done. This is how fast you should find a saddle point. I'm really thinking to put this problem as a free response problem because it's lots of nice writing there. Second one is, what if it's positive? So let's do negative or positive, right? So if negative. If positive, now we have two choices left. It's minimum or maximum. You just need to look at this damn number. It's supposed to be a good problem on a test, right? Don't freak out. If this one is positive, if fxx is positive, now you have positive, positive. It's so happy that it is minimum because it's at the bottom of the smiling face, okay? The kindergarten explanation. Right? But it's nice because it helps to memorize things. If this thing is negative, then it's like, it's kind of grumpy.
It's like it's winking.
It's winking and being grumpy at you being winking. I don't know why. So the nose gives you maximum. How good this problem is. Amazing problem. Right? Nothing can go wrong with this. Does this cost 14 points of the exam? Nice. It's like free 14 points. You just need to write down everything. Yes?
How many free response questions are there?
Usually 3. You remember from the previous exam?
Is it gonna be like last time? Or
Yeah, it's the same thing.
So like A, B, C, D for each one?
Maybe. Well, this is ABC, right, already. This is like find this, find this, find this, find this, right? So it's, yes.
Are fxy and fyx the same thing?
In this class it is, because functions are nice and they're just nice. Now remember the hard problems of the global? Shh. Let's use last 5 minutes. You remember global maximum, global minimum? These are too long, so I try to avoid using this. It was on the square, on the parabola. I don't think you would do good, so I try to avoid. And the last 5 minutes, and maybe we're not gonna get kicked out, we'll see, will be about double integrals and how to switch limits of operations. Double integrals. Double integrals, since we just learned it, especially the polar ones, I will try to use my quizzes for this because I just gave you the quiz and you feel good about it. For the polar one, I will give you a very obvious problem. So your job is just to know what is happening. And the very obvious problem looks like this, for example. Integral from -2 to 2, and integral from 0 to a square root 4 minus y squared, x squared plus y squared raised to the 3/2. It's from the review. This is a very nice, obvious problem for polar. Convert into polar. First thing you see that this is going to be r squared raised to the 3/2. Don't forget the power. Second thing you need to remember the pirate formula. R dr d theta. So this is your job not to forget the r part, right?
What part?
R part. Now there's a r squared raised to the 3/2 inside. Did you get how I got this part? Yeah? I just changed it right away. And now you're afraid of limits. I understand that. So here's my hint how to do it. Whatever is standing inside, in this case it's x, write down x equals only for this inside part. And sketch the graph of what you see. X equals 0. That is this line, x equals 0. X equals a square root of 4 minus y squared. Either you know what it is, or if you don't, square each side. Add together x squared plus y squared equals 4. That is a circle. X squared plus y equals 4 is a circle radius 2, but x should be positive or 0. X is left and right running. So I need to have a right hemicircle. Is this as hard for you?
Yeah. Actually, not really.
Right? So hard or not?
How do you know the positive?
Because it's a square root. Square root has to be positive or 0.
So
That's
if it wasn't square root, then it would be the whole thing.
Then the whole thing, exactly. Now, why it's important? Because now we know the radius. Radius is jumping from 0 to 2. Radius is standing inside, so it's going to be here from 0 to 2. Make sure you're consistent. Theta is always outside. Theta is how much we're spinning around. How much did we spin?
Pi over 2 to negative pi over 2.
Negative pi over 2 to pi over 2, exactly.
Well, how do you know that?
Because like this. You're starting from minus pi over 2, that is minus pi over 2, and then you rotate to cover the whole circle, but somehow you stop halfway through. You stop at pi over 2. And also you need to know that this is 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? So you need to know the basic stuff, yeah?
Putting negative pi over 2, not 2 pi over 2.
2 pi over 2. Good question. Usually it's just a standard thing to do it like so.
Can I put in degrees?
from here to have a counterclockwise rotation. There's many ways, you're right, there are many ways to describe the same half of the circle, but to keep the counterclockwise rotation, which is international, we do from here to here. Yeah. So just remember it, I would say. But you're right, you can do it in different ways. So you see, this is full credit. How nice is that? And then maybe we'll ask you to integrate this or not. I don't know. Yes.
So if we use 3 pi over 2, it won't be the same thing.
If it's multiple choice part, it's not going to be there. That's what I should say. But the 3 pi over 2, no, still should be fine.
Really?
Because I was wondering if we get the same.
Depends how you describe it. It should be 3 pi over 2.
And then
No, it's not going to work, I think. Yeah, no.
It's gonna work.
What will happen if we forgot your pirate equation?
Then you lose points.
How many?
Yeah, but what if
And then I made several very nice videos how to change limits of integration with triangles, all that kind of stuff. So review my videos. Kind of that's all. That's all we learned. No global maximum, global minimum.
Wait, there's none of that?
I have 2 questions.